So all this time with subnetting, we've been doing something called same length subnetting. And there is a problem to this approach. The problem is we've been designing these networks purely from the perspective of how many networks do I need? Creating a subnet mask that's the same for every single network based on how many total quantity of networks I need, and it was not even a consideration. We didn't even think about how many hosts do we need in each one of those networks. And that would result in a problem. For example, take a look at this. We start here with a single base network, a /24. That one network gives us the whole range of host space. So in that last octet, we've got from 0 to .255. That's the full range of host addresses. Now we know that two of those we can't use, right? The .0 and the .255. But that circle there represents the full range of host space in that last octet. Now if we used our previous approach of same length subnetting, and let's say we needed 4 networks, like this building right here needs 4 networks. Well, what's the approach we would have come up with? Well, we would have said, okay, well, if I steal 2 networking bits, if I steal 2 subnet bits, there I go. They'll give me 4 subnets, right? So now we've got that circle there. We divide it into 4 sections, a pie of 4 equal slices. And they're all equal because every single network is going to have the exact same subnet mask. They're all going to be /26. Right? And with a /26, what do we know? Going back to this right here, with a /26, we know that each one of these networks is going to have 62 host addresses. 62 host addresses. So 64 addresses total. The network address, 62 host addresses, and then the broadcast address. So 64 addresses total. So that's what you see right here. Network 1, 2, 3, and 4. And they're all equal, right? Network 1 has it starts at the network address of .0, broadcast address ends on .63. Network 2 begins at address 64, ends at broadcast address .127. Network 3 begins at network address 128, broadcast address 191, and then the remaining host space is network number 4. So we do have our 4 networks, but we have a problem here. Check it out. Network number 2, it requires more than 62 hosts. He needs 80 hosts. 80 hosts won't fit into any of these slices of pie right here. It's not going to fit. Not only that, look at some of these other networks. For example, look at network number 1. There's only 5 hosts in that. And yet we've allocated 62 hosts in that one network. That's far more host space than we really need. We got a whole bunch of extra bits that aren't even being used because this network is far larger and can support far more hosts than is actually needed. So this is the problem with same length subnetting. We're completely ignoring our host requirements, which means we might end up with subnets that are either far larger than we actually need, and it's a complete waste of space, or just the opposite. We might come up with subnets that are too small. Like these, none of these subnets here will fit our requirement for network number 2. So this is where we take a different approach, something called variable length subnet masking. Now with variable length subnet masking, here's basically what we're going to do. Instead of starting with the position of, okay, I need to figure out how many total networks I need, and then create one subnet mask that will come up with that total quantity of networks, we're going to do it from a different approach. Instead, we're going to say, I'm going to create my subnets based on how many hosts are needed in each subnet. Oh, this subnet's really large. It needs a lot of hosts. Okay, that'll have a subnet mask of maybe a /26. Oh, and then there's a tiny little subnet over here that only needs 4 hosts. Don't need a /26 for that one. Why don't we use a /29 for that one? And so we're going to create subnet masks of variable sizes, hence the name variable length subnet masking. They're finely tuned or finely designed based on the host requirements that each network actually needs. So let's do the same example here. In this particular case, base our subnets based on hosts required. So typically the way you do this is you start with the largest network, the network that's going to have the biggest host requirement. So I say, okay, let's see here. 80 hosts. I need 80 hosts. Well, going back to my chart, if I need 80 hosts, what does that mean? That means I'm going to have to use a /25, doesn't it? Because a /25 will give me 126 hosts. Anything else, like a /26 or /27, won't support the 80 hosts that I need. So for that particular slice of the pie, it's going to be pretty big. It's going to support 126 hosts. So there we go. That's what I'm going to divvy up for network number 2, a /25. So .0 is going to be my network address. .127 is going to be my broadcast address, and then I'll have 126 hosts in the middle for use. I'll use 80 of them, and that gives me a little bit for future expansion. Okay, now we go to the next one. We say, okay, what's the next largest one? 22 hosts. Okay, let's go back to here again. 22 hosts. Well, it looks like according to this, to get 22 hosts, I would need a /27. That'll get me up to 30 hosts. All right, so my next network is going to be a /27. Not quite as large of a pie. I should say the piece of the pie is not as large as the other one. And with /27, so notice here, in my first network, I already used up all the addresses from .0 to .127. Those were used up in the first subnet. So I know that the next subnet, regardless of how big it's going to be, when I start, even before I look at the next subnet, what do I know about it? I know it's going to start with .128 because that's the next available address. The previous one ended on .127, so the next one is going to start on .128. So I already know my starting network number is going to be 199.199.128. The only thing I need to figure out is, what's the subnet mask going to be for that? Well, I just did that. I said, well, based on 22 hosts, the subnet mask needs to be a /27. And with a /27, we saw that gives me a total of 32 addresses, 30 host addresses, plus the network, plus the broadcast, gives me 32 addresses. So I take my starting network of 128, I say, okay, let's see, what's 128 plus 32? Oh, that's 160. So that's my next network. So I know now that network number 3 is going to be the 128 network. His broadcast address will be 159. And then the next network available will be .160. I say, okay, let's see here. The next largest one is network number 4. So apparently network number 4 is going to be 199.160. That's where it's going to start. So we rinse and repeat. So the question now is, okay, how big of a slice of the pie does that network need? What kind of subnet mask do I need for that? Well, 12 hosts. Let's see here. If I go back, 12 hosts, that means I need a /28. /28 will give me 14 hosts. So with a /28, I have a total of 16 host combinations, right? I've got the network address, 14 hosts available, and the broadcast address, which gives me 16. My networks are in increments of 16. So if I take 160 plus 16, that gives me 176. That will be my next, and in this case, final network. So my last network, which knows what I was doing here. I started with the largest network, figured out the appropriate subnet mask for that network, figured out where that network ended, And then I said, okay, now I know the next available address will start my next network. And then I repeated the process. And I went from largest all the way down to smallest. So in this particular case, network number 1 is the smallest. That I could get by with a /29 mask. /29s are always in multiples or increments of 8s. All right, if we go back to this, /29s are always in increments of 8s. So if it started at .176, 176 plus 8 is .184. So that's where that little slice is going to fit for network number 1. And now I've got all this space here from .184 to .255 as all unused space for future expansion. So I could have more networks in the future if my building grows. So with same length subnet masking, all we cared about was the quantity of networks that we needed. Therefore, each resulting subnet had the exact same subnet mask. But that was very risky. Some of those subnets might not be big enough for our really big networks. With variable length subnet masking, we're creating each subnet to be finely tailored to the host requirements of that particular network. Actually, before we talk about classless interdomain routing, let's just do one more example of VLSN before I throw a couple of quiz slides at you. Okay, so let's say that we had this. Your starting network we'll make it easy. Something that falls on a nice even bit boundary. 200, 200, 200.0. Here is what you need to create subnets. So let's say we've got engineering. Let's not give names to them. Let's just say network 1, which is going to require 70 hosts. Network 2, which is real tiny. That only needs 2 hosts. Network 3, which is going to require about 16 hosts. And network 4, which is going to require 49 hosts. Okay, so how do we use variable length subnet masking? Like I said, we start with our largest network, our biggest one. So that will clearly be network number 1. And using our subnet cheat sheet, what kind of subnet mask do we need to give us at least 70 hosts? Well, we need a /25. With a /25, that will give us 126 hosts. If we go any bigger than that, if we do a /26, it's not a big enough slice of the pie. A /26 only gives us 62 hosts, and we need 70. So we got to do a /25. Okay, so we start with 200, 200, 200.0, but now it's going to be a /25. And we say, okay, when our networks are in multiples of /25s, I should say when the subnet mask is a /25, let me rewrite this here. What increment or multiple are the networks? Well, with /25s, they're always in multiples of 128. So if I add 128 to this, that will give me my next network. So let's see, what's the next one? Oh, that's 49. So remember, I'm going from largest to smallest. So 200.200.200.128. Because I said that was my next available network address. Okay, but this network here doesn't necessarily need a /25. That's the subnet mask that was appropriate for this size network. What subnet mask do we need that's appropriate for 49 hosts? Let's go back. 49 hosts. with 49 hosts, we would need a /26. That will support up to 62 hosts with a /26. So we put that down here. That's our new subnet mask for this particular slice of the pie. And now we ask ourselves, okay, in /26s, our networks, our subnetworks, are always in multiples or increments of what? They're always in increments or multiples of 64. 64. So I take my existing network and I add 64 to it. 128 plus 64 is what? 192. That's going to be my next available network. 200, 200, 200.192. Once again, don't worry about your existing subnet masks. Now we need to come up with a subnet mask that's appropriate for this network, 16 hosts. Well, to support 16 hosts, I need a /27. That will give me up to 30 hosts. I could almost do a /28, but /28 wasn't quite big enough. It was 2 hosts shy, so I need to go with a /27. So /27, and with /27s, my subnets are always in increments of 32. They're always in multiples of 32. So I take the number 32 and I add it to my existing network number. What's 192 plus 32? That is 224, which gives me my last network. And finally, what subnet mask is appropriate to support 2 hosts? That fits just perfectly with a /30. /30 supports 2 hosts. And that, my friends, is variable length subnet masking. Before I show a couple more quiz questions to you, what questions do you have? All right, let's give you an opportunity to practice this. I know I'm skipping the slide on classless interdomain routing. I will come back to that. I just want to give you a chance right now to practice variable length subnet masking. Starting with the base network that you see right there, use VLSM to divide the single network into multiple subnetworks appropriate to fit the requirements shown below, just like I did in the whiteboard. So I will give you 1 minute to work on this. Okay, let's work through this one. First thing was, hopefully you reordered them by largest network, I should say largest host requirement to smallest host requirement. So from what we saw before, the biggest network was network number 3, marketing, with 100 hosts. So we start with that one. And we needed a /25 subnet mask to support up to 100 hosts. /25s mean our subnets are always in increments or multiples of 128, so our next network was 128. So that's what we moved down to the next one. the next largest network, which was 49 hosts. That requires a subnet mask of /26. /26s are always in increments or multiples of 64. So we take 192 plus 64, and that gives us our next available network. I'm sorry, 128 plus 64. So we take our existing network of 128, add 64 to it, and our next available network was 192. And so that's where we put on network number 4. With 19 hosts, we use a /27 subnet mask. /27s are always in increments of 32. So we take 192 plus 32, that gives us 224. And that gives us our final network. And let's do one more of these. Same thing. There's your starting network. There are your host requirements. I'll give you 1 minute to work through this question. All right, time's up for this one. And here are the answers. So we start with our largest network here, which was the one requiring 220 hosts. For that, we actually need a /24, which supports up to 254 hosts. So that consumed all of 140.140.0. So 140.140.1 would be our next network. So that's where we put on network number 3 with 45 hosts. A /26 is an appropriate subnet mask to support 45 hosts. Our networks are always going to be in multiples or increments of 64 with a /26. So we take our existing network of 1.0, we add 64 to it, and that gives us 1.64. That's what we place on our next smallest network. Only 6 hosts, that means we can get away with a subnet mask of /29. /29s are always in multiples of 8s. So 64 plus 8 is 72, which goes on our final network, which gives a subnet mask of /30 based on its host requirements. Okay, let's go back to that one slide I skipped so that you understand what that concept is of classless interdomain routing. What's that talking about? So classless interdomain routing is just basically a fancy way of saying that this whole idea of classes, A, B, and C, is now irrelevant. Irrelevant. Now what do I mean by that? Well, if you had TCP/IP software running on your laptop or your PC that followed the classful rules, it might still let you do subnetting, right? If I start with a class B address, I could put in a subnet mask that instead of a /16, which is the classful mask, it might allow me to put in a subnet mask of /17, /18, /30, whatever, as long as I didn't go less than /16. With classless interdomain routing, that means the whole idea of classes is completely gone. That means you can apply any subnet mask you want to any address. For example, let me bring up one right here. So right now, I'm logged in. This is actually a router. It's not a host. But I can go into his interface. And I can say IP address. Let's give him a class B address. Anything that's 128 or greater. Let's say 130. Now look at this. If this was a classful system, it wouldn't let me do that. Because 255.248, what is that telling the system? That's saying, okay, of that address I just gave you, the first 8 bits, so the whole number of 130 is networking bits, and of the second byte, 5 of those bits are networking bits. So it's basically saying of that number, 13 of the bits, if I did that right, 8 plus 5, 9, 10, 11, 12, 13, yeah, 13 bits are networking bits. If this is a classful based system, it'd say, no, 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 you can't do that. 130 falls in the class B space. This number, at least 16 bits have to be the networking. You can give me more, but at least 16 of the bits have to be networking because this is class B. But because this is a classless interdomain routing device, oh, I guess it would help if I actually did it on an interface. It takes it, no problem. He says, look, you can give me any 32-bit IP address, I don't care, as long as you tell me where the dividing line is between network and host. As a matter of fact, I could do something real crazy. Look at this. IP address, let's give him the same address. And what if I say, look at that. What's that telling him? That's saying of that address that you have, only the first 2 bits represent your group. Everybody in your group has an address beginning with 10. Because if I break 130 down, it starts with the 128-bit on, the 64-bit off, 10. And this subnet mask is saying that's all you care about. Your group is 10 anything. This is classless interdomain routing, where the whole idea of A, B, or C is completely thrown out the window. The subnet mask is in charge of dictating where the dividing line is in these bits between network and host.